Okay, the old Joker didn't do so good last trip. Didn't even get her started. Of course, I only had it started once prior to that. Problem seemed to be spark. We was lacking spark. So I got her tore down here. Back up a little bit here. We got her sitting up here on our little engine stand and all tore apart. See if we can figure the spark problem out. This is the wire, this black wire right here is the wire to the condenser. It was pinched all the way through the casing. This is the same wire that kills the motor when you shut her off. That's the wire that you short to ground. So it just didn't seem like that's what was causing our spark problem. It just don't seem to me like that should have been it. But maybe it was. We're going to put her back together and check the timing real close. Make sure everything's right up to spec. And go from there. Got the old points there. They didn't look quite right. They was wide open. Supposed to be 18 thousandths, and holy cow, I had every bit of 25 in there. So that wasn't helping. We're going to keep looking. Got her opened up here and a few shots of things. Here's that wire to the condenser. Just not convinced that was all the problem. Follow that up to the points there, and gap on the points, that wasn't good either. You know, a lot of little things may be the culprit on this one, but we're definitely going to find out. I had to get that back off. We got to get a wire hooked to them points so we can get the ohm meter hooked up and get this timing right where it belongs. Don't look like it's been set properly. Quick little side note there. You ever can't get this to work quite right for you, you got to pull that black wire that goes down to the condenser off the end of your points there, your little lug that holds. There's two of them on there. One's usually blue, the other one's black. One that goes to the condenser is a black one. That's the one that's got to come off. But once you get that black one off there, you can unplug your coil and connect your ohm meter right to the terminal that goes into the coil, your spark plug coil, and then you can get your flywheel back on and you're ready to check them points. Give you a quick little shot of what we got going on here. Getting ready to set that timing, man. We're going to get precise about it. Got the ohm meter hooked up. It's all ready to go, so we'll know exactly when them points break open, because on these motors it is when the points open up that the spark gets sent to the spark plug. We got our trusty old calipers there clamped to the head and right down through the spark plug hole, measuring the spark plug, or measuring the piston I mean, and where that's at. Let's see if we can get you a little shot here. Yeah, we might be able to read them numbers. Back that motor up. Get that thing so that thing reads 0 as it hits the top and starts back down the other side. Boy, there we go. One more time. Them points ought to be opening up when that thing reads about, that 5 on the end don't count. That's half thousandths. We're not going to worry about that. That's 286 thousandths. And she starts up, and them points ought to open up at somewhere right around 165. Somewhere right in there. Currently they're opening at about 215 thousandths. So we're going to make some adjustment to that. Yeah, we're within a half hour reading top dead center, so we'll call that a good reading, and we got to change when these points open. Okay. Okay, we're going to give you a little shot of the final result here. Well, it's not the final result, but this is where we're at. This is where it all comes together. Got everything set up. Got the ohm meter hooked up right there. You can see that's on. It's actually a 0.6. And what we'll be looking for is for that thing to go what they call over limit. Here, we'll give you a quick shot of what that looks like. We're looking for it to go to that. We want to know the exact moment that it does that. It's when our points are actually opening up. And we still got our calipers neatly attached to the top here. So we can take a reading over there and know where the height of our piston is. And then a spec we look up in the manufacturer. So first thing we got to do is rotate this motor. Oh, there it is. There we are. Push down our calipers over here. We had about 163 thousandths. Let's take another reading. I was getting 171 earlier. Push that back down. See, we're at about 291 now. Okay, that'll be going down. And let's try it one more time. Yeah, getting about 160 that time. Things are moving a little bit. We'll spin her through a few more and, man, make a call. We're still in the spec. The spec is, well, not really. Yeah, we are. We're looking for 157 to 177, so we're in spec, but we're going to check her a few more times. Yeah, I don't mind saying we've been battling the Joker pretty hard here. Still can't get her to run right. Completely went through that ignition system, as you saw, and that all looks really good now. My next attack was on the carburation, and man, had this carburetor apart about 6-7 times now to make sure everything was right. Everything in it is brand new now, right down to the high-speed check valve. I've never dealt with them before, but I did get a new one in this one. And she still won't run without the choke on. So we're pulling too much air from somewhere or not enough fuel, one of the two, and since I've been through the carburetor the way I have, I gotta believe we're getting enough fuel and we're just pulling too much air. So we're jerking the lower end apart here, and this is the PTO side. And bearing looks good. A lot of dirt inside there, but you gotta remember this is a 71, 72 motor, so it's 40 years old. The seal doesn't look happy, but just like the ignition system, doesn't look good. It's definitely been pulling something through. There's a couple of rubber O-rings in here, and they don't look happy. They're pretty much O-ringed out, I guess. So we're gonna keep delving deeper into this motor and replace all these seals down in the lower end and see what we get. Okay, and that old Joker, got him tore apart. I'm gonna give you a little picture of that here in just a second. Everything is just borderline. Maybe it's good, maybe it's bad. I don't know, maybe it's just a bunch of little problems creating one big one. I sure hope so, because ain't much left. I'll give you a shot of what we got here. There she is, all tore apart. And there ain't much to these motors. It's one of the things I like about them. One of the reasons I can't understand why I can't get it running too, there's a grand total of the ignition system. And my favorite's the wiring harness. Right there's a wiring harness that makes her all run. Battery hooks up to them too. Man, the crank looks good. Inside look good. All the bearings are in in top-notch shape and definitely original equipment. I'll say Australia on them. Austria, however you pronounce it. But anyway, we're waiting on a seal kit now, and we get that in, we'll throw this back together and see what happens. We got them new seals in, and they went in nice. Everything looks good. Got to paint up a few more parts while we had her all tore down. But she still don't want to run right. I can get it up to a steady maybe 3,500 RPMs and it'll run good and steady. I heated her right up like that. We got her good and warm, but something still ain't right. We don't have to have the choke on when we're running this 3,000, 3,500 RPMs. But man, if you punch the throttle, she just goes right over on her face. She's spitting a bunch of fuel out the carb. The plug is wet all the time. I'm still running my jets quarter turn. Low speed's quarter turn heavy. We're putting more fuel to her, and the high speed is a quarter turn in. We're cutting it off. So we're getting back down into this, and we're going to look at this electrical system again. I'm not convinced my timing's exactly right. A little something my father taught me here a long time ago. I actually made a video about this once and decided not to keep it in there, but we're going back and we're revisiting this, so we're going to get in here and have a look at this. What this is when the magnets on the flywheel line up with the coil that creates your spark that's on the stator plate itself. There's a gap, there's an end gap between that coil and that magnet. If we look in there, man, that's hard to see. Man, had to get a little better adjustment on the old camera there. But this piece down here, as we look through this window, this is the actual magnet itself right here. And this piece up here, that's the end of the coil, the windings that create the magnetic field for all that spark to take place. This distance in between the two of them, believe it or not, has a spec. And Rotax, in their ultimate wisdom, and they are a high-performance motor, you know, compared to the rest of them, they're hard to beat. This is one of the reasons. Has made that adjustable. Not only do they give you a spec, but they put a little adjustability to it. Dad always told me to keep an eye on that. Something I kind of forgot about. Think of every now and then, especially when you're having these kind of problems. Anyway, that gap is supposed to be from 1/4 of an inch to 7/8 of an inch. Man, she's wide. Got you a mile there to get her in. But this one's running right down around 1/4 of an inch. I mean right on 1/4 of an inch. Again, another minor problem. I think this motor is just full of minor problems, and maybe we'll get them all worked out, because every time I fix something, she does run a little better. Alright, we're going to get into this and get that moved and see what happens. One might ask, how am I supposed to measure that gap in there? Well, it ain't easy. You got magnetic fields flying around, so you really can't stick nothing metal in there. It winds up stuck to the magnet and you can't do nothing. But here's the method I've devised for taking care of that. I got me a wood popsicle stick and some sidewalk chalk. So let me back this camera out. We're looking at it right there as the coil and the magnet itself. Back this up a little. Just take you a popsicle stick and lay the old sidewalk chalk to it. Get it chalked up good. Gonna have to revert to the old dial calipers. We got the digital readout stuck in the piston hole, or in the spark plug hole. So we know that this popsicle stick is 375 thousandths wide. In the mean, the middle, in between 1/4 of an inch and 7/8 of an inch, is 562 thousandths. So to be perfect, we would need to be at 562, which is right there, right in there somewhere. So we know that the gap should be wider than the popsicle stick. Well, it's not, but it is wider than 1/4 of an inch, and here's how we tell that. Now that we got our stick chalked up, let's zoom back in. what we can do with that and scrub it against that coil a little bit. What that'll do is that'll leave you a line in the chalk. Where your chalk scrubbed off, and you can measure to that line. Boy, you're going to be pretty close. I'm seeing about 364 thousandths. And I wish it was closer to a ½ inch, but we're going to try it right there. I think we found the problem.